Unit 5 is a fantastic improvement over the previous versions of the framework, but it's got a lot of features in it that most Java developers don't realize are there and can really make your life easier, especially if you just understand how they work. That's what I want to talk to you about today in this episode of Tales from the Jar Side. When you talk about functional interfaces, you're talking about a concept that was created in Java 8 to describe an interface that can be assigned a lambda expression or a method reference. If we look in the Java API, so this is the java.util.function package, they talk about functional interfaces. And these are a set of interfaces that were added to the library to represent lambda expressions or method references. The definition of a functional interface is that it has a single abstract method. It can also have default methods and static methods. Those don't count, but it can only have one single abstract method. Functional interfaces are the targets for lambda expressions or method references. Okay, that's all good. What do we have in the library? In the Java util function package, they have 4 categories of functional interfaces. Even though it looks like there's a lot of interfaces here, they fall into only 4 main categories. We have consumers that take a single argument and return nothing. We have functions that take an argument of type T here, let's say, and return a value of type R, so they can be different if you want. And then we have predicates, which take a single argument and return a Boolean. Those are used to filter things. And finally, we have one that we're really going to need, supplier. A supplier takes no arguments and returns an object. These interfaces have been in Java now since roughly 2014 when Java 8 came out. Now let's look at JUnit. In JUnit 5, they have a class called assertions. So here's the assertions class. It's an org.junit.jupyter.api, and all the normal assert methods are in here. And if you look at it at all, you're rapidly going to run into the fact that they use something called an executable. Like, look at the assert all method. The assert all method either takes a collection of executables or a stream of executables or a vararg list of executables. So the natural question is, what the heck's an executable? Well, let's take a look. If you look at executable, it says this is a functional interface and can therefore be used as the assignment target for a lambda expression or a method reference. But what is it here for? Well, a functional interface is similar to runnable, because when we look at the abstract method, you'll say it takes no arguments and returns nothing, just like runnable does. But executable can throw any kind of exception. In fact, here's the detail. The single abstract method name is execute. It throws a throwable and returns void. Now, if you played with lambda expressions or method references at all, you know that lambda expressions and exceptions don't really go together. They're very much like oil and water. They don't mix well. You generally wind up either having to put a try-catch block right in the body of your lambda expression, or you have to refactor to use a method and use a method reference to delegate to it. It's just not pleasant no matter what you do. But that's only if you're the one who has to catch the exception. The beauty of JUnit defining an executable that throws a throwable is that when they put this in their own assertions, they're the ones who have to catch the exception. We don't have to deal with it. Our code is just as simple as it might otherwise have been. Let's take a look at an example. Now, here are some of the methods in the assertions class that take an executable. There's assert all, assert timeout, and assert timeout preemptively, one that interrupts the thread of the test, one that doesn't. Assert throws and assert throws exactly. And here's a simple test to kind of illustrate all of them, just looking at things in the library. So first of all, assert all here, as we saw, takes a vararg list of executables. So executable ... And here's what an executable looks like. It takes no arguments in the lambda expression, and then you have your arrow, and then the right-hand side is supposed to return void, but might potentially throw an exception. So in this assert timeout, it takes a duration saying, okay, I'm willing to wait this long and an executable. And the documentation says, assert that the execution of that executable will complete before the timeout is exceeded. Now, assert timeout versus assert timeout preemptively just has to do with whether you're running in the same thread or not. I'm not concerned about that. I'm looking at this executable. So what I'm saying here is I'm willing to wait 100 milliseconds. My executable here is a thread.sleep of 50 milliseconds. And notice I don't have to wrap that sleep in a try-catch block. Whereas the sleep method throws an interrupted exception. It's really annoying when you use it in practice, having to wrap that in a try-catch or declare a throws clause. Well, here we just say thread.sleep, and of course it may throw the exception, but that exception is JUnit's fault and problem, not ours. Now, of course, this one's going to pass because I'm only sleeping for 50 milliseconds. I'm waiting for 100. So assert timeout should be fine. Now, here is likewise an assert timeout preemptively. So nothing really different there. Same concept, just whether I'm willing to interrupt the thread or not, and both of these are going to pass. Here is an assert throws. The docs on assert throws say, tell me what exception class you're expecting to get, and then assert that the execution of the supplied executable throws an exception of that type, and then it'll even return the exception. Now, I'm not doing that here, but if you want the exception itself, you could then find out what the cause is or the method, the message that's inside it, whatever you like. Here, I'm simply saying, let's throw a null pointer exception. And then I assert that we received an exception of some type, and a null pointer exception is a kind of exception. There's also, of course, assert throws exactly, which only passes if the returned exception is exactly the expected type. So here I have to make this null pointer exception. And again, we can get the exception back. We could further interrogate it. But the executable is the lambda expression, parentheses, arrow, and in this case, it's a block lambda because I'm throwing an exception manually like that. That's executable. They're used everywhere. Let's move on to our next one, which is a supplier. Now, going back to the assertions class, you'll notice in all these assert equals methods, they take an expected value and an actual value, or expected, actual, and a string. See, in JUnit 5, if you want to supply your own error message, it has to come last now. But that's no problem. You could put in your own custom error message if you like. But all of these are overloaded so that the last argument is not necessarily a string, it's a string supplier as well. Now, wait a minute. That supplier, what supplier is that? That's the one, as this says, from java.util.function package, the one we were just looking at. To remind you, here in java.util.function, the supplier interface has a single abstract method called get that takes no arguments and returns a value. Where do you use suppliers? Why would they want to overload for suppliers? Well, looking back at the API again, let's look at the detail because the description of all three of those assert equals is the same. Assert that expected and actual are equal. But let's look at the one that takes a supplier. It says, if necessary, the failure message will be retrieved lazily from the supplied message supplier. And that's the key. That's the payoff. Why create the error message if you don't need it? Let's look at an example. So I have a class here called lazy error message test. And I have a private method for creating an error message. Now, in reality, this method that I'm planning to work with would be in some other class, but I'm putting it right in the test here to keep everything nice and self-contained, make it easy to see. So what does this create error message do? It prints out that we're in it. We could log that or print it to the console, and then it returns this constant. keep that in mind. Right now, all we're doing is returning a constant. We'll change that later. Now, here is a test that I'm calling an eager test. It's using assert true rather than assert long here. Assert true takes a Boolean and a string, asserts the supplied condition is true, fails with the supplied error failure message. Okay, but here's the problem. I'm asserting that true is true, and true will in fact be true for most values of true. My second argument is that private method, and the only reason I've got it as a method call is because I want to log this. I want to see that this method gets invoked. And when I run this test, you will see, yes, indeed, we are creating the error message even though we don't need it. I mean, after all, the assertion passed. Why do I need an error message? I don't. However, down here, I'm using parentheses arrow to the left of that same method call. And that transforms this assert true from one that takes a Boolean and a string to one that takes a Boolean and a string supplier. And that makes all the difference in the world, because now when I run this, you will see no call to the create error message method. There is no need to create the error message because the test passed. Now let's see how the magic happened. I mean, it doesn't just happen automatically. Let me go inside the assert true method. And here's the assert true method inside assertions.java. That turns around and calls the same method on another class. Fine, layers of indirection for the win. Let's go inside one of those. And here's the special part. Assert true here takes a Boolean and the supplier, and it says, if not condition, if the condition fails, then we'll go grab the error message out of the message supplier. Somewhere in this hierarchy, they call get on the message supplier to retrieve the error message. But if the condition passed, we're out. We're done. We return. The error message is only returned if we need it. And that's what they mean by retrieving the error message lazily. Now, of course, this was just returning a constant. That's not a big deal. That's really simple. There's no time cost to that. But imagine if it wasn't. Imagine if, in fact, this read data from a file or pulled information out of a database or acquired something across a network and wrote to some complex log or whatever. We don't want to do all that work if the test is already going to pass. Why are we doing that work to create the error message? And all you have to do to convert the eager one to a lazy one is put parentheses arrow to the left of it. And now it's a supplier. And the message will only be retrieved if you need it. That's the supplier version. That leads me to the last one I want to talk about, which is ThrowingSupplier. Now, here we are back in the assertions class in JUnit 5. And if I search for ThrowingSupplier, there's not too many of them, but there are a few. There's the assert timeouts overloads and the assert timeout preemptive overloads, of course. And there is assert does not throw, which takes a ThrowingSupplier. So there's those three methods with all their overloads that take a ThrowingSupplier. So what the heck's a ThrowingSupplier? Well, you probably are already anticipating this. If you go into ThrowingSupplier, it's a supplier that might throw an exception. But what's the key? What makes suppliers special? They return a value. So if you look at the mechanism with a ThrowingSupplier, you'll see this is a way of invoking a method that may actually return a value, but also might throw an exception. Let's look at the example now. I have here ThrowingSupplyer's test, and I'm going to illustrate assert does not throw and assert timeout, and arguably assert timeout preemptively. Now the process I'm going to use is to read all the lines out of a file. I have here a couple of constants, a location of a file that is in the GitHub repository under source test resources, and I have the name of a file that does not exist. Here's the method I want to test. Once again, that would be in my regular code if this was a real system, but I'm putting it right here just to make this easy to read and easy to follow. This is using a method called read lines from a file that takes a path and uses the wonderful read all lines method from the files class in Java New I/O. That takes a path and it reads all the lines from a file. I mean, isn't this great as an aside? I mean, no more buffered reader and read line and doing everything in a while loop and catching all the exceptions. No. You've got a one-liner to read all the lines from a file and retrieve them as a list of string. Kay Horseman wrote a wonderful blog post about this recently. I'll put a link in the description, and it keeps you from writing all that extra code. Here's the important part for our purposes, however. Notice that this guy throws an I/O exception. Not a big surprise. Just about everything in the java.io package can throw an I/O exception, and this is exception. So let's read a file that exists. Well, I know this file exists, so I wrapped my ThrowingSupplier here in assert does not throw. See, assert does not throw takes a ThrowingSupplier and it says asserts that the execution of the supplied supplier does not throw any kind of exception, and if that passes, it returns the result. And that's the key. So here I've wrapped read lines from a file in a ThrowingSupplier. Again, no arguments, returns a value, get back all the lines from the file, decoded in UTF-8 and everything, and then I could check that they have the right number of lines and all of that. Great. If I'm going to try to read from a file that does exist, I might as well have a test that reads lines from a file that does not exist. So that's this one. Of course, now I'm back to an assert throws that uses an executable. Remember, we started with that one. This isn't a ThrowingSupplier, but I figured if we're reading from a file that did exist, might as well read from one that doesn't and check the expected type. So when you read lines from a file, we should get a no such file exception, and that's easy enough to check as well. Down here, however, I have the assert timeout, and the assert timeout documentation says, here's how long I'm willing to wait, the duration, and here's the ThrowingSupplier, and it says asserts that the execution of the supplied supplier completes before the timeout is exceeded. And if it does, we get back the results. So I'm going to wait 100 milliseconds to read all my lines out of the file. And assuming that completes within 100 milliseconds, here's my list of string, and I can check that there's a right number and use the result out of that. If I can't read 7 lines from a local file in under 100 milliseconds, I have bigger problems than not understanding functional interfaces in JUnit 5. Although still, got to be a good thing to be able to understand these functional interfaces in JUnit 5. Now, I have set it up so that I could run all 3 of the tests that we just discussed, and in fact, they do all pass. It's all good, and hopefully now you understand much better those 3 major functional interfaces that are part of the assertions in JUnit 5. You know where to use them and you know how they help. There are a handful of other interfaces inside of JUnit 5, things like ThrowingConsumer, which is a consumer that throws an exception. But these occur far less frequently and some are very specific to the framework. Don't need to worry about those. If you know about the 3 we discussed, however, you should be much more productive and write much more understandable and useful tests in the future. If this tip worked for you, please subscribe, and that way you'll see future examples of tales from the jar side. Thank you very much.